Welcome to NTI Day 29, finding missing side lengths using Trig. We're going to do 4 examples today, which is more than we've done in the other videos, and that's just because this topic is a little more confusing than the other ones we've done. So I want to give you as many examples to look from as possible. So we're going to start with example 1. We've got a triangle here. It's a right triangle. All of these are going to be right triangles. And you can tell that just from that square in the corner. We've got one of our angle measures as 64 degrees. One of our side lengths is 25, and the other side length is x. So that's all the information they've given us for this triangle. And our goal here is going to be to find the value of the side labeled x. And we're going to do that using only the information that they've given us so far. So as you can see, 64 degrees, that's what our angle theta would normally be. That's what we're going to be using as our theta, kind of. We're not going to write theta, but that's what we're going to do the same kind of thing with. So this angle 64 degrees that we have at the top, the other labels that we have are x, which is opposite, and 25, which is the hypotenuse. So if you remember, sine is opposite over hypotenuse. So we're going to be using sine to figure out what x is with this triangle. So instead of theta, we're going to have 64 in there. So sine of 64 degrees equals opposite x over hypotenuse 25. So that's just the setup of our problem here. And our goal is to figure out what does x equal. So now we just need to get x by itself. So I can do that by multiplying 25 on both sides of the equation. So we get 25 times sine of 64 equals x. And then to figure out the exact value of 25 times sine of 64, you can type that into a calculator. You can Google it. It'll probably come up there. If you have a graphing calculator at home, you can just use that. If you have a calculator that does your trig functions, you can do that as well. I just typed it into my phone calculator and I got x equals 22.5. So 22.5, and that's just rounded to the nearest tenth. And that's going to be our answer. So that's the length of that side x. I would show you how to type it in on your phone calculator, except I'm using my phone to record, so I can't really do that. But if you turn your phone sideways, it will pull up a whole bunch of other options, and sine, cosine, and tangent are some of those options. Again, you can also always just type this into Google and it should come up as this, because Google has a pretty good calculator on it. And then we're going to do example 2 next. So we've got our 47 degrees. Remember, our degree that they give us, we're going to treat it like a theta. So the other labels we have are x and 12. Now, x is opposite of 47, 12 is adjacent to 47. And I know that tangent is opposite over adjacent. So I'm going to use tangent because that's the information they gave me. So tangent of my degree equals opposite, which is x, over adjacent, which is 12. And then I'm just going to do the same thing as the last problem where I try and get that x by itself. So I'll multiply by 12. So 12 times tangent of 47 equals x. And again, I just typed that into my calculator and it gave me 12.9. And again, that's just rounded and that's all good, that's fine. So there's 2 examples, one of them using sine, one of them using tangent. I think the most challenging thing with these is figuring out which trig function to use, but you can find that out just by checking what labels have they given us. So like, for example 3, our angle at the top there is 18. So that's kind of our theta. And then we've got an x and we've got a 34. So now this x is adjacent to our angle, and this is and that 34 is our hypotenuse. So cosine is adjacent over hypotenuse. So I'm going to use that because those are the labels that they've given for this triangle. So we've got cosine of 18 equals, my adjacent is x, my hypotenuse is 34. And then same thing, very similar to the other ones, multiply by 34 on both sides. Because that's just going to cancel that denominator out. So we'll have 34 times cosine of 18 equals x. And then again, just type that into a calculator, into Google, into your phone, and that'll give you x equals 32.3. And remember, whatever x equals, that's just that side length that we're missing, that we were looking for. So now we know the length of one of our sides, from another one of our sides, really. And then last, example 4, which is going to be a little bit different. So we've got two sides, our angle. We're going to treat that like our theta. And then this is 27 is opposite, x is hypotenuse. Opposite hypotenuse, I know that that is sine. So I'm going to use sine. So sine of that 63 degrees is opposite 27 over hypotenuse x. Now the only thing that's really different about this one is that the x is on the bottom instead of on the top, which means we're going to have a little bit of an extra step. So we want to get x alone, but first we need to get it out of that denominator. So I'm just going to multiply by x on both sides, because that'll cancel that out. And we'll have x times sine of 63 equals 27. But we still need to get x alone. It's not done yet. So I'm going to divide by sine of 63 on both sides. So that'll give us x equals 27 over sine of 63. And then again, just type that into a calculator on your phone, on Google, wherever. And it should give you 30.3 as your answer for that side length. So those are our 4 examples on finding missing side lengths using trig. There's not that much to it. It's just kind of figuring out what goes where and which function to use. If you have any questions, make sure to email me or comment or send a text through Remind, whatever is easiest for you. If you want any further examples, let me know that too, and I can show some more. But if this is pretty good and easy for you, that's great too. Tomorrow we'll have a assignment where you'll practice this more, and then we're almost done with trig. That's all I got. Have a nice day. I hope everyone's doing well and staying safe and healthy.